of discontinuities. Okay. First is called removable discontinuity, and the other one is called non-removable. Why it is called removable? Why it is called non-removable? At the end of it, we will understand. Okay. So in removable, again we have removable is the case when LHL equal to RHL. Removable is the case when LHL equals to RHL. That means limit exists. Non-removable means LHL, or simply say limit does not exist. Whatever be the reason, limit does not exist. Okay. Show me your copy. Show me your copy. Don't flip the pages. What you are writing? I told you will regret it. We will be covering whole board and you don't have space. You have shut down your ears completely, yes or no? You have a task at home, yes or no? Whatever is being taught, your mom, dad, they will see whether you have written or not. Doesn't matter whether you have heard or not. Yes or no? They will see whether you have written or not. Are you attending these classes on behalf of somebody else? That you just copy the notes and go back and give that notes to somebody? So removable where limit exists, non-removable where limit does not exist. Okay? Now understand, this removable can again be discussed in three parts. Can again be discussed in three parts. And you will give me the name of these three parts. Okay? Let's say I said limit exists. Okay? In removable, we are discussing the cases in which your limit exists. That means what is the left possibility that the function is discontinuous. Something is wrong with f of a, yes or no? Something is wrong with f of a. Here only two are there. Let's say f of a not defined. F of a not defined. Okay, I'm going to draw the curve. Let's say this is your x equal to a. And let's say, and this is the curve where, yes or no? Now left hand limit, right hand limit equal. Left hand limit and right hand limit equal. Now what happens to x equals to a? What is the value of function at x equals to a? Not defined. What happened to this? Is it missing? So what do we call this continuity? Discontinuity? Missing point discontinuity? Yes or no? Because f of a is missing. So it is called missing point discontinuity. Missing point discontinuity, it is when your f of a is missing. That means it is not defined. Yes or no? Now let's say f of a is defined. F of a is defined but not equal to what? Yes or no? This is your f of a. Yes or no? Now tell me this f of a value, this point, this point is all alone? Yes or no? Your curve is somewhere here and this point is, don't know what it is doing. Yes or no? It is all alone? Can I say it is isolated? That's what it is happening in our corona also. Somebody who is showing some symptoms, we isolate that person. Yes or no? Alone. Yes or no? So here also this point is completely isolated. So that's why it is called isolated point discontinuity. It is called isolated point discontinuity. Isolated point discontinuity. So in removable discontinuity we have two types. Whether function is defined, then we have isolated. If function is not defined, then missing point. Clear? Now we will come to our non-removable one. Okay? Non-removable one. We will talk why it is called removable and why non-removable after this is all over. Now limit does not exist. Limit does not exist. Are you awake? Limit does not exist. So what are the chances, what are the cases when limit does not exist? LHL is not equal to RHL. Second case, LHL is equal to RHL but not finite. If LHL equals to RHL, that means limit exists or not? That means it will be in the left hand part, removable discontinuity. Here we say limit exists, that means LHL equals to RHL. So all those cases will be here. I am saying limit does not exist. LHL not equals to RHL, one case. Other? LHL equals to RHL, but not equals to? LHL, RHL not defined. Yes or no? LHL equals to RHL maybe, but not finite. Yes or no? Third discontinuity I will tell you, third case I will tell you. Let's say this is your x equal to a. It is tending to, let's say, infinity. Okay? It is tending to infinity. Yes or no? So what is happening to limit? What is happening to limit? Quickly. What is happening to left hand limit? Tending towards? So it is called infinite discontinuity. Infinite discontinuity when you have one of the limit or both tending to positive or negative infinity. You understand? When one or both tending to positive or negative infinity, then we have infinite discontinuity. Okay? LHL or RHL or both tends to infinity. Tends to infinity, then we have what? Plus minus infinity is also okay. Okay. Then we have infinite discontinuity. Now, opposite to infinite discontinuity, we have other case. Let's say yes or no? Left hand limit finite, right hand limit finite, but not equal. Yes or no? Left hand limit is finite or not? Right hand limit is also finite, but not equal. So it is called finite discontinuity. LHL, RHL, finite. LHL not equals to RHL. Yes or no? Now the last one, let's say this is 1, this is minus 1. Near x equals to a, your function oscillates too much between two finite values, let's say plus 1 and minus 1. Okay? Plus 1 and minus 1. But you cannot determine which value it will approach at as v tends to x equals to a from the left hand side or right hand side. Yes or no? When you are not able to determine at which value they are going to approach, then obviously we have a problem. Yes or no? So again, this is your discontinuity, and we have talked about this discontinuity. Sine 1 by x. Sine 1 by x as x tends to 0. Sine 1 by x as x tends to 0. Then the input in the sine is what? Infinity. We already know output of the sine is between minus 1 to plus 1. Yes or no? We already know output of the sine function is always between minus 1 to plus 1. But we don't know exactly which value it will approach. Yes or no? It can be anything. It can be minus 1 in between also, plus 1 also. Yes or no? So this kind of discontinuity where we cannot determine which value it will take, it is called oscillatory. Oscillatory discontinuity. Oscillatory discontinuity. So your discontinuities are divided into first two parts, that is when limit exists and when limit does not exist. Limit exists, that means removable. Limit does not exist, that means non-removable. Removable, again two parts, missing point and isolated. Non-removable three parts, infinite, finite, oscillatory. Yes or no? Now draw this whole chart in landscape form. Do you know landscape? Can you draw this full? That's why I told you, wait for me. Yeah, like this. You don't need scale and all this. Yeah, it's okay. Here on top of oscillatory, I have written when limit oscillates between two finite values and we cannot determine at which value it will approach. Okay? When limit oscillates between two finite values and we cannot determine at which value it will approach, then we have a problem and called oscillatory discontinuity. When limit oscillates between two finite values and we can't determine at which value it will approach, when limit oscillates between two finite values and we cannot determine at which value it will approach. Done? Are we done? Done? Okay, let's discuss now why it is called removable or why it is called non-removable. One pen, two pen, three pen, scale also. Preparing for your marriage? Obviously it looks like, neat and clean everything. Okay, let's focus here. Discontinuity, two parts, removable and non-removable. What do we understand by removable discontinuity? Why it is called removable or why it is called non-removable discontinuity? Answer is in the name itself. Removable discontinuity. We want to remove this discontinuity. Yes or no? We want to remove this discontinuity, and all of the cases under this head we can actually remove discontinuity and make it continuous again. But all the cases in this under this head we cannot remove discontinuity and it will always remain a discontinuous function. Okay? Now again let's come back to our strict condition for continuity is left hand limit equals to right hand limit equals to f of a. Yes or no? Yes or no? Now here this left hand side we have left hand limit equals to right hand limit, only the problem is f of a, and here the problem is with left hand limit and right hand limit. Yes or no? Now understand, if I talk about, let's say, infinite discontinuity, okay? So let's say I have ln x minus a. Okay, I have a function ln x minus a and my limit is tending to a. My x is tending to limit x tends to a. Yes or no? Then as x tends to a, x minus a will tends to 0 or not. That means ln 0 is what? Infinity on the negative side. Yes or no? If I want to make this function continuous, then I have to do something to remove this minus infinity limit. Yes or no? And the only possibility is change the function itself. Yes or no? There is no way that my limit will not go to minus infinity if I don't change my function. Yes or no? I have to change my function itself. If I have to change my function itself, then it is non-removable, because if we are changing the function, then we are having a new function. I want to make the same function continuous. New function, not my concern. I want to make my existing function continuous. Yes or no? Here in this case, if I want to make it continuous, then I have to change my function itself. Yes or no? Because it is tending to what? Let's say if I talk about this curve, that means this left hand limit must tend to a finite value, and in reality it must tend to this value itself. Yes or no? That means my graph is completely changed. That means this function will be completely changed. Yes or no? The graph is basically representing the function or not? So obviously my function itself will be changed. So if I am changing my function, if I am changing the equation itself, equation of the function, then it is a new function. If it is a new function, I wanted to make my existing function continuous, not the new one. So, not possible. Yes or no? Let's say in this case, left hand limit and right hand limit not equal. Again, if I want to make left hand limit and right hand limit equal, that means this part, right hand part, must go here. Yes or no? So again your graph is changing. Again your graph is changing. That means your equation of the function is changing. That means again we have a new function. Yes or no? So again it is non-removable, whether it is your infinite or finite. Oscillatory, sine 1 by x. Sine 1 by x. Again, 1 by x, where it is standing I don't know. If I want to make it to approach to a particular value, again my function will change or not. The equation of the function will change or not. So again a new function. Now it is not what? Removable. It is not removable. Yes or no? But let's come to here. Let's come to here. Your left hand limit is equals to right hand limit. Only the point is missing. Yes or no? Here, left hand limit equals to right hand limit. Only the point is misplaced. Yes or no? Let's say signum x. Or let's say mod signum x. When x is positive, signum x will give me +1. When x is negative, signum x will give me -1. But mod sign is there. Yes or no? So graph will look like this. Only this point is missing because modular sign is there, so x is positive, signum x is positive, that input in the signum is positive, that means +1, output is +1. If x is negative, signum x is negative, input in the signum is negative, that means -1. Modular sign is there, +1 is output. Yes or no? But when x equal to 0, signum is 0. So this is the point. Yes or no? This is the point. Now, if I want to make this function, continuous, then I have to worry about only one point or not. If I define, let's say, it is signum x when x is not equal to 0 and 1 when x is equal to 0, then my function becomes continuous or not. This equation is not changing, only one point I am shifting or defining. Yes or no? So whenever you have missing point or isolated point, you can actually redefine function to make it continuous. That means that discontinuity can be removed. That's why it is called removable discontinuity. Left hand limit must be equal to right hand limit. If limit exists, then you can redefine to make it continuous. If limit does not exist, then it can never be made continuous again. That's why it is non-removable. Is it clear? So I will give you a question for homework. Check type of discontinuity. Limit x tends to 3, x square minus 9 divided by x minus 3. Oh. check 1 over cosec x, what type of discontinuity this function has at x equals to 0.